Hello, my name is Hannah Barbour. I'm a second year doctoral researcher in the Department of Health Sciences. My research is looking at whether there is an association between vestibular dysfunction and falls risk in older adults. Falls have a significant impact both on a personal and wider economic level, with 1/3 of over 65-year-olds falling at least once every year, which costs the NHS more than £2 billion per annum. In order to not fall, you need to maintain your balance, and this is a complex process involving input from 3 different sensory systems: your vestibular, visual and somatosensory systems. The vestibular system, which I'm focused on, is key in maintaining balance as it stabilises gaze during movement and provides feedback as to your head's position and movements. All 3 of the sensory systems are known to deteriorate with age. However, it remains controversial the impact this deterioration due to ageing has on their ability to maintain postural control. In order to establish whether there was an association between the level of vestibular dysfunction and falls risk, an online questionnaire was distributed to older adults via a range of organisations that support them. They were asked to complete this at baseline and then at 6 months follow-up. The questions were regarding their falls history, past medical history, physical activity level, fear of falling, alongside a range of vestibular symptoms outcome measures. 3 measures were chosen as they all record slightly different aspects of vestibular dysfunction. The dizziness handicap inventory assesses the impact that any symptoms have on somebody's quality of life. The vertigo symptom scale assesses the frequency of any vestibular symptoms, and the visual vertigo analog scale assesses the frequency of any visual vertigo symptoms, which is a subset of vestibular dysfunction. 216 participants completed the baseline study 1, with 66 of them going on to complete the follow-up 6 months down the line. A logistics regression was completed to determine whether there was an association between the participants' level of vestibular dysfunction measured on the 3 measures and their falls history in the last 12 months at study 1, and this showed that for those reporting mild or moderate symptoms on the dizziness handicap inventory or mild symptoms on the vertigo symptom scale, there was a significantly increased risk of reporting a fall in the previous 12 months, and the odds ratios are shown in the top table, but they ranged from 2.5 to 7.39 times more likely when compared to those reporting no falls. It was then looked at to see whether the participants' score level of vestibular dysfunction in study 1 was able to predict future falls. So this was compared to whether they then reported any falls by study 2, which is 6 months down the line. And this showed that there was no significant association between any level of vestibular dysfunction and falls. So although this shows that there appears to be an association between level of vestibular dysfunction and previous falls history, it's not yet currently able to predict future falls, which would be the most useful in clinical practice. However, this was a relatively small study with only 66 participants completing both parts of the study, and they were only followed up for over a 6-month time period. Therefore, the next steps of the research is to determine whether, if participants are studied over a longer time period, whether there is any predictive value to level of vestibular dysfunction and falls risk.
Hi, my name is George Collett and I am a PhD student in my final year. I will be presenting a qualitative study from my PhD thesis, which is titled Exposure Worry: The Psychological Impact of Perceived Ionising Radiation Exposure in British Nuclear Test Veterans. So what is the question being researched? Just to give some background, during the 1950s and 60s, the United Kingdom had a nuclear weapons testing programme, and many of the veterans involved in the programme have claimed adverse health effects as a result of ionising radiation exposure. But aside from any possible physical health effect, the psychological impact could be an issue, and this generally relates to worry. For example, worry about possible adverse health effects in themselves and in their descendants. So the aim of this study was to explore exposure worry, but also the broader psychological impact of being involved in the nuclear testing programme. So why does this research matter? Well, the majority of the work examining the psychological impact of perceived exposure has been conducted in other contexts, for example, nuclear power plant accidents. but there is relatively little work conducted in the nuclear test veteran population. The nuclear test veterans are also all older adults, so it presents a unique opportunity to examine the psychological impact across a lifetime. But also, mental health is generally not so well understood in older men as it is in younger age groups. So to address the research question, I conducted 20 semi-structured interviews with test veterans, and the interviews were transcribed, and I analysed the data using thematic analysis. And this generated 3 broad themes. And the first theme relates to health effects. And generally, the veterans in this study were not particularly worried about adverse health effects in themselves or in their family members, although it did persist, but only in a few cases with regards to their grandchildren's health. But what was more important was the sense of responsibility and subsequently guilt, particularly in those veterans who believed their family members' health conditions were a consequence of their ionising radiation exposure. And I also found that there was a perceived power dynamic reported by these veterans, and several of them felt angry and frustrated due to a perception that authorities were negligent or had deceived the veterans at the time of the tests. For example, they had not been given adequate protective equipment, or they were withheld information about any possible health risk. So what do the findings mean? Well, it was rather unexpected that the majority of these participants weren't worried about their exposure to ionising radiation. And this means that we cannot presume that perceived exposure will result in the same psychological consequences as in other contexts. And there are 2 main reasons for this. Firstly, the nuclear testing program was relatively isolated in comparison with other contexts, such as nuclear power plant accidents. And nuclear power plant accidents are often marked by radical social and economic change, which means that whatever is driving the psychological impact is actually quite hard to unpick. But we also need to consider this specific cohort too. So these veterans were young men at the time, and actually the majority of them enjoyed the nuclear testing program. As I mentioned before, there was little health risk communicated to them at the time, and this health risk was actually communicated through the media in the 1980s, by which time most of these veterans had children either born healthy or with health conditions. Either way, their children's futures are not necessarily uncertain, and so worry is not necessarily relevant. But the findings regarding guilt and anger raise 2 important implications. First of all, of course, health conditions occurring in family members would be naturally distressing, but one should consider whether the guilt experienced by a veteran who believes they are responsible for their family's health condition is in excess of any psychological impact experienced by individuals who do not believe themselves to be responsible for their family's health condition. And the findings regarding power dynamic highlight the need for authorities to be transparent when dealing with radiological exposure scenarios. For example, frameworks of risk perception propose that risk is amplified when trust in authorities is low, and that anger is a likely outcome when the authorities are perceived as responsible for threats to people's well-being. Thank you very much for listening, and thank you very much to the Nuclear Community Charity Fund for funding this research.
Hello, my name's Jade and I am a 3rd year PhD student at Brunel University. Today I'll just talk to you about one section of my PhD, which is a systematic review that we're undertaking, looking at transgenerational effects of ionizing radiation exposure. I'm just going to focus on the human side to begin with. So if I start with a bit of an introduction, heritable effects of parental radiation exposure before conception remain poorly understood and quite controversial. The largest group for this to be studied in was that of the Japanese A-bomb survivors, which currently show no transgenerational effect in the children. However, an increase in birth defects and DNA mutations in the offspring of Chernobyl cleanup workers have been reported, although this is debated. Little et al. published a comprehensive narrative review in 2013, which also looked at this question, and he concluded that animal and cellular studies do suggest an effect in offspring of people exposed to radiation, mostly 1 gray and above. However, this has not been identified in human studies yet. So to explore this in a bit more detail and to give an up-to-date review, we have completed a systematic review of this question, and this includes a range of health outcomes including stillbirths, congenital abnormalities, DNA mutations and cancer. I'll go on to methods now. So firstly, we needed to identify our literature, so we ran a search term across 3 different databases, and then we need to identify all of our papers, and then we extracted information from these papers, such as things based on the methods that you used and the results and the endpoints. Then we had to assess the internal validity, so this is the risk of bias for each individual paper, and once we did this, we pulled all of the data together, and we can either assess this as a narrative or a quantitative approach, such as a meta-analysis. So we included all study types, offspring exposed before conception, all types of radiation, dose ranges and dose rates, and all original articles since 1988, but we didn't include any reviews or non-peer-reviewed literature. So here's a quick flow diagram just showing how many papers we started with. So we started with 2,444. As we screened through for different criteria, we ended up with 101 human papers left, and we registered our protocol with Prospero. You can see the ID there, and we're also following guidelines of OHAP. So I just briefly go over some results that we have so far. So this is showing a heat map for all stillbirth studies of people exposed to ionizing radiation occupationally. So it basically just shows different types of biases and the corresponding bias score. So dark green means a low risk of bias, and pink and red is high risk of bias. So then once we grouped all of our papers based on health outcomes such as cancer, DNA mutations and congenital abnormalities, we also further grouped into exposure types such as environmental exposure, occupational exposure, medical exposure and A-bomb survivors. And then following OHAP guidelines, once we did this, we have to rate the confidence in the body for that evidence. So how we do this is we bring the papers together, and then we can either upgrade or downgrade based on certain criteria. For example, you would downgrade if there's inconsistency within the results, or you'd upgrade if there's a large magnitude of effect or if you see a dose response. And then you can draw conclusions for that grouping. That grouping. So I won't go over this too much, but basically here are some of the conclusions that we conclude from our results. So for example, evidence for congenital abnormalities among offspring of occupationally exposed groups, there's moderate confidence, but the majority of the studies show no effect. Sorry, show an effect. Whereas, for example, evidence for genetic anomalies amongst offspring of A-bomb survivors gave a low to moderate confidence, but all of them studies show no effect. So our next steps is to see if we can pool any of this data together and do statistical analysis, such as a meta-analysis, and we plan to use RStudio and run a random effects meta-analysis first, and then maybe move on to different statistical analysis depending on our data sets. Thank you for listening, and I hope you enjoyed this talk.